Hi, hello, welcome back to our channel. Today we are going to discuss about the crash course. The chapter name is the thermodynamics. So in this already you know that from the previous classes what is the heat. Heat is a form of energy and temperature is the degree of hotness or coldness of the body, and you know how to use the thermometers and how to calibrate the scales and all this. But in this chapter also we can say that it belongs to the heat only, but in this we are going to discuss about macroscopic properties of the matter, like pressure, volume, temperature, mass and all these. If for the gas, how these are showing the effect, everything we are going to discuss. In this first we are going to discuss about specific heat, molar specific heats. Already you know normal specific heats, in that molar specific heats. Molar specific heats we are going to discuss in two ways. One is the molar specific heat at constant volume. It is represented by CV. Same here also, how to define this one. CV equals to the amount of heat energy required to raise the temperature of 1 mole of the gas through 1 degree centigrade. So instead of 1 unit mass, here we are taking 1 mole of gas, that is called the molar specific heat at constant volume. CV equals to 1 by N into dQ by dt. Here dQ is the heat energy and dt is the temperature, not time. From this you can write this change in heat energy is NCV dt. NCV dt. We do one problem also. If suppose CV equals to 5 by 2 and N equals to 4 moles, dt equals to 40 degrees centigrade. How to find out the heat energy? dQ equals to, this is 40, this is just we have to multiply all this 5 by 2 into 4 into 40. This is after that 84,400 joules. 400 joules. So like that we can calculate the change in heat energy and the specific heat at constant volume, and we can able to find out the change in temperature also based on the given data. Then we are going to discuss about molar specific heat at constant pressure. At constant pressure, it is represented by Cp. Cp equals to same, the amount of heat energy required to raise the temperature of 1 mole of gas through 1 degree centigrade. Here also we can able to find out the heat energy in terms of Cp. We can write it NCP dt. So these are the two types of the specific heats. And here we are going to the relation between Cp and Cv. See, Cp minus Cv equals to R. This is the relation between two specific heats. You know that R is the universal gas constant. This is 8.314 joule per mole degree Kelvin, and R equals to 2 calories per mole degree centigrade or degree Kelvin also we can take it. See, if Cp equals to 5 by 3 R, 5 by 3 R, find Cv. How to find out? So clearly we have to we can take it, suppose the answer is in terms of CGS unit, instead of R we should take the 2 calories. Then Cp is how much? 5 by 3 R minus Cv, and here R. Then Cv equals to, after taking LCM and all this, 5R minus 3R, 2R by 3. But instead of 2 we are taking 2 calories, answer is 4 by 3. So like that we can able to find out the Cv when you know the Cp value. Even you can able to find out the Cp when you know the Cv. So these are the, this is the relation between Cp and Cv. Then the ratio of Cp by Cv is called the gamma. This is the ratio of specific heats. This value is different for different gases. For monoatomic gas, Cp, Cv and gamma, you should remember that. For diatomic gas also we have to remember what is Cp, what is Cv and all this. So for the diatomic gas, monoatomic gas, like carbon monoxide, argon, neon, like that, we are calling that monoatomic gas. For monoatomic gas, Cp, Cv and gamma. This is the 5 by 2R. This is the 3 by 2R. This value is how much? 5 by 3. For the diatomic gas, we can take it 7 by 2R. This is 5 by 2R. This gamma is the 7 by 5 like that. For polyatomic, what we are taking, this is 4 times of R. This is less than 1 means this is 3 times of R. We can take it 4 by 3. You must remember this table for monoatomic gas like argon, neon, carbon monoxide like that. Diatomic gas, hydrogen, then O2, N2 all belongs to diatomic. More than that we can treat as a polyatomic gases. These are the Cp and Cv values for that. You should remember Cp minus Cv equals to R, and we have to remember Cp by Cv, that is the ratio of the specific heats. It is represented by gamma. So these two are the two types of molar specific heats. Then we are going to discuss about the zeroth law of thermodynamics. What is the zeroth law of thermodynamics? If two bodies are separately in thermal equilibrium with the third one, then these two are also in thermal equilibrium with each other. See, two bodies we are taking. Suppose this and this, both are two bodies separately in thermal equilibrium with this board. Then what happens? This marker and this cap also having the same temperature. This is called the zeroth law of thermodynamics. Now we are going to discuss about the first law of thermodynamics. What is the first law of thermodynamics? When we are providing the heat energy to the system, it is utilized into two ways. What is that? To increase the internal energy and to do some mechanical work. Instead of mechanical work, you can express in terms of pressure into change in volume also. So this is the first law of thermodynamics. But how to take the sign convention also, it's very important. Heat energy increases. I am showing with arrowhead. So you can say dq is positive. Then heat energy decreases. You can say otherwise not increasing, not decreasing. Heat energy giving to the system, and heat energy taking from the system or taking or extracting. So we can take it dq is negative here. If internal energy increases, you can say du is positive. If internal energy decreases, you can say du is negative. Then work done by the system, we can take it is positive. Like that, work done on the system, we can take the negative. So we must remember this sign convention belongs to the first law of thermodynamics. But the thing is, we do one problem. We are taking one system, work done on the system, suppose dW equals to 40 joules. Internal energy increases. I am taking that is the 60 joules. Find the heat energy. I didn't take any sign convention here, but what I said while that problem, what they have mentioned that work done on the system means immediately you can take it. This is the negative. Work internal energy increases means this is positive. Then dq is how much? What we are taking? 60 minus 40. Answer is the 20 joules. So like that, based on the sign convention only, we have to use the first law of thermodynamics. Not only this one, work done by the system. Work done by the system is, by the means what we are taking, like positive 40 joules. Internal energy decreases. Means I am taking minus 60 joules. Then how to find out the heat? Heat equals to minus 60 plus 40, how much? This is the minus 20, means heat is extracting from the system. Like that we can understand. So based on the sign convention, we can say, and we have to do the simplifications from the first law of thermodynamics. Then we are going to discuss about, after first law of thermodynamics, There are four types of thermodynamic process are there. First one is the isothermal process, second one is the adiabatic process, third one is the isochoric process, and fourth one is the isobaric process. So in that, what is the first one? First one is the isothermal process. In the case of isothermal process, temperature is constant. At constant temperature, we have to calculate the variation of pressure with volume or variation of volume with pressure. So this is the slow process, we can take it. See, isothermal process. Isothermal process means it is one of the thermodynamic process. First one, here you can take it, T is constant. T is constant means change in temperature is 0. Here what is the specific heat? You can say the specific heat, you know that 1 by m into dq by 0. Always you remember that in isothermal process, specific heat equals to infinity because change in temperature is 0. Always temperature is constant. Suppose you are taking ice. When you keep in surroundings, what happens? It is taking the heat energy from it is taking the temperature from the surroundings. Then temperature is same. So if it is, suppose you are taking one hot body, then it comes to room temperature. Why? It is giving the heat energy to the surroundings. Like that, always we can observe in isothermal process, that is the temperature is constant. So here all gases are obeying the Boyle's law. Boyle's law. What is the Boyle's law? At constant temperature, pressure is inversely proportional to the volume. We can write it P1 V1 equals to P2 V2. But you should remember one more formula here. Work done in isothermal process is 2.303 nRT log 10 V2 by V1. In terms of pressure also you can express, that is 2.303 nRT log 10 P1 by P2. P1 by P2. So N is the number of moles and R is the universal gas constant and T is the absolute temperature. So if they are using they are giving the volumes, we can using this one. If they are giving in terms of pressure, we can take this one. Then we are going to the one more process. That second one is the adiabatic process. Adiabatic process. So here which is constant? Heat energy is constant. Change in heat energy is 0. It is isolated from the surroundings. There is no connection between the surroundings to the system and system to the surroundings. Suppose we want to take the ice cubes from one place to the another place. Which material we are using? We are enclosing into the bad conductor. Why? Heat energy is constant. So inside heat energy is not changing, with the outside heat changes. So here you can say in adiabatic process dq equals to 0, and in this case specific heat is 1 by m into 0 by dt means, so in adiabatic process specific heat equals to how much? 0. Here all gases obey PV power gamma equals to constant. It should be right, P1 V1 power gamma equals to P2 V2 power gamma. When you know the P1 and P2, we can able to find out the V1 and V2. Suppose V1 is the monoatomic gas and V2 is the diatomic gas. Just now we know that that values we have to remember, especially for these problems. Like that you should give the temperature and volume relation TV power gamma minus 1 equals to constant. It should be right, T1 V1 power gamma minus 1 equals to T2 V2 power gamma minus 1. So this is the relation between absolute temperature and volume. Then relation between pressure and temperature, P power 1 minus gamma T power gamma equals to constant. It should be right, P1 power 1 minus gamma T1 power gamma equals to P2 power 1 minus gamma T2 power gamma, also we can take it. So all these belongs to adiabatic process, and here you should remember that work done equals to NR T1 minus T2 by gamma minus 1. And in terms of pressure and volume also we can express, that is P1 V1 minus P2 V2 by gamma minus 1. So this is about the isothermal process, this is about the adiabatic process. The next process is the isochoric process. At constant volume, the system changes from one state to the another state. That is called what? Isochoric process. Then fourth one is the system changes from one state to the another state at constant pressure. You can say that is the isobaric process. Then another process are reversible process. What is the reversible process? The process which is retraced back, that is called the reversible process. Like big ice melts and it becomes to water, water becomes to steam, steam becomes to water, water becomes to ice. So this is called the cyclic process, but here it is retraced back into the same position. So this is called what? Reversible process. Like that, you throw one glass, it will break, we can't retrace back, that is the irreversible process. Like that, quasi-static process means always the process which is in equilibrium with the surroundings, and it is very infinitesimally slow process, means that process is called the quasi-static process. Then second law of thermodynamics is there. There are two things are there. One is the Clausius, another one is the Kelvin statement. In the case of Clausius and Kelvin, what they have given conclusion, without any external agent, we can't, heat does not flow from cold body to the hot body. It is impossible. So this is belongs to the second law of thermodynamics. Then we are going to discuss about the heat engine. What is the heat engine? It is the device to convert heat energy to the mechanical work, that is called the heat engine. It is having the three parts. One is the source, means at high temperature, sink is at low temperature, and in between working substance. For petrol engine we can use as a petrol, for fuel, for steam engine we can use as a steam, and for this heat engine we can take it, three parts are there. First one is the source. It is at high temperature, heat energy is we are taking Q1, and this is the working substance. For diesel engine we can take diesel, for petrol we can take petrol and all this, and this is the sink, it is at low temperature. This is the source and this is the sink. Heat rejecting to this one, taking from here and giving to this, here heat energy is Q2. In between it is doing some work. You can say that work done equals to Q1 minus Q2. But how to find out the efficiency of this one? Eta equals to W by Q1. So we can write it Q1 minus Q2 by Q1. It should be right 1 minus Q2 by Q1 also. Or in terms of absolute temperature also, 1 minus T2 by T1. Many people are doing mistake. Look here, suppose T2 equals to 27 degrees centigrade. They are giving in problem. T1 is the 127 degrees centigrade. Find the efficiency of heat engine, means directly they are substituting in this. It's not right. We must convert into degree Kelvin. So eta equals to 1 minus T2 is 27 plus 273, 300 degree Kelvin, and this is the 400 degree Kelvin. After simplification, this is how much? 1 by 4 means 0.25%. 25% also we are taking. In 200 it is the 25%. So like that we can able to find out the efficiency of the heat engine. Then we are going to the reversible process. Based on that, reverse of heat engine is called the refrigerator. In refrigerator, what we are observing here in refrigerator, we can go through the, here also it is having three parts. Source, temperature is T1, working substance, and another one is the sink, and this is the sink at T2. But the thing is, look here, heat is extracting from the cold body only. Suppose refrigerator, when we touch that one, always what happens, we feel hot there. We feel hot. Why? Always it is rejecting the heat energy. Then it is giving to the source. This is the T1. Then here working substance, you can take it as usual. But working substance also like this, you have to give Q1 minus Q2. But coefficient of performance, we can take it alpha equals to Q1 by W. So we should write it Q1 by Q1 minus Q2. It should be right T1 by T1 minus T2 also. So this is about the refrigerator, and this is about the heat engine. So, and one more thing, Carnot's engine is there, that is also cyclic process, and you study that. So this is about the thermodynamics crash course. and almost I have given all chapters from the first year and the second year. Only few chapters left from the first year, kinetic theory, then a system of particles and fluid mechanics. From the second year I have completed like moving charges and magnetism. Those are the pending. I will complete as early as possible. Whatever I have completed, better you should go through the formulas and work out the problems on that. Mostly we are getting that good marks in objective type. It may be NEET or it may be MSET or it may be like mains also. So always do hard work and practice number of problems, and be ready to write the exam thoroughly. You should prepare these formulas also. Okay, thank you everyone. Subscribe my channel and share to your friends also.